Hello viewers, welcome back to another session with me. Welcome to Master Leaders Online Academy. If you are new in this channel, guys, do consider subscribing to our channel. Make sure you turn on the post notification bell for more exciting videos. Wow, guys, I have a very good stuff to unveil to you in this video. Don't worry, in this video, I have a very mind-blowing content for you in engineering methods, solving problems. So I want to teach you another tips in a very short while. But please, guys, do not skip any part of this video. Remember, every bit of our video are always encrypted with principles that works. So if you understand these principles, you stand a chance to become a master. What actually helps people to gain mastery over a particular area of their career is that they understand principles and boundary conditions. So you understand that when you know principles, you become a principal. And when you understand boundary conditions, you will not overstep your boundary. So without wasting much of our time, let's quickly dive into the marker board as I begin to hold you by the hand again and walk you through the process of solving another aspect of force system. Now on the board we have problem 11. Okay. Now we are asked to reduce the force system or the system of forces. Reduce the system of forces and couples to the simplest system using point A. In other words, taking point A as our reference point. Alright? Now, what do you understand about this question? Reduce the system of forces, one, and couples to the simplest system. Now, get it clear. This is the principle number one. Anytime you are given a system or a structure and you are asked to reduce it to its simplest forces, its simplest couple. Remember, couple is the same thing as moment. Alright, Tony? Is the same thing as moment. Okay? Couple is moment and moment is couple. I'm not saying husband and wife, oh, not that. Couple. Alright? So couples are moments and moments are couples in structures. So indirectly we are asked to what? Reduce the system or what? To its simplest forces and its simplest moments. So what do you understand by this statement? In a simple word, in just one line, to reduce a system to its simplest forces, it means that solve that system or resolve that system to a point where you have only one horizontal force, only one vertical force, and only one moment. Remember that you can have a force acting upward, acting downward, which are in line with vertical or inclined. You can have a force acting backward or forward and inclined, which is in the x direction component. Then you can have a moment which can either be clockwise or anti-clockwise movement, right? Rotation in clockwise direction or rotation in anti-clockwise direction. You can have it that way. So now, this question says that we should solve this point, this system, to a point where we have only one existing force in x direction, only one existing force in y direction, and only one existing moment in this system. So we have to have just three values. But quickly, let's look at how many values do we have here initially. We have 1, 2, 3, 4. Are you there? Now we have respective distances. This is point A from A to this point. 2 meters are from A to this other end is 4 meters. From A to this point is 3 meters. So let's take, for instance, we want to identify some of these joints. We can simply say let here be B, let this point be C, and let this point be D. Okay? That's it. Now remember that anytime you are dealing with force system, the first thing you do is to draw the free body diagram. Remember that this system we have now, we have a section for it. A section for it. It has dimension, length, breadth. But we do not need this length, we do not need the breadth. We only need a line to represent this whole L section. Right? This is L section. Okay? So what do we do now? To remove this thickness of this shape, what we are going to have as its equivalent result is what we call free body diagram. Alright, so to get the free body diagram, we only need the line of action. This is the line of action and the line of action, the skeleton of the system. So the skeleton of this system is L. So you just draw a free body diagram. Okay? Now, for the free body diagram, take your L. This is L. This is the L. So, this is point A. This is point B. This is point C. And then point D is mid of AC. Middle of AC. This is point D. Now, this is the free body diagram of this L shape. Now, the next thing we are quickly going to do is to position the loads. Remember that from here to this end is 4 meters. While from here to D is 2 meters. Are you there? This is it. So let's quickly position the load. At C, we have a downward load of 85 newtons. So let's quickly put the load here. This is 85 newtons. Remember, what we just have here is the free body diagram of this system. Free body diagram. So this is it. Now we have this force. Then again at D, we have a force, an inclined force that make angle 45 with X. So we have angle of 45. Let's assume this is 90, okay? This is 45. And we have 68 newton. Angle it makes with X is 45 degrees. Then in between A and B, we have a moment anywhere. And the moment is 280 newton meters. Then finally, we have at B a force here, which is acting upward, and this force is 33 newton. Okay, so these are the joints that we have. So this is the free body diagram of this guy. Then from B to A, as we have it, is 3 meters. So the first thing we are quickly going to do is to resolve this force along X and Y axis. Why do we need to resolve? Because we need only one S component, we need only one Y component, and we need only one moment component. That's what we need. And we know that we have vertical forces here, and we have inclined force. Remember, any inclined force has an attribute to X and Y axis, right? So all we need to do now is to first of all resolve this force to Y direction. So when we resolve this force to Y direction, this is what we have. We just merge it to the Y direction. It becomes 68 sine 45 degrees. This is this force in its vertical direction. This is how it will look like. So this will become the value if this force is resolved to Y. Now, if this force is resolved to S, remember that this is the arrow, so if you still put it down this way, this is what you have. This is how the force will look like. This is the force. Okay? So what will this be? This will give us 68 cos 45 degrees. This is what we have. So when we resolve the force along S, it becomes 68 cos. So we now have this. Remember, now that we have resolved this system, this force along X and Y, it is assumed that nothing is here, right? We have already resolved it to X and Y. So nothing is there for now. You have already made use of that force and the angle. So let's remove it. Now we can solve. So what we do first is what? Resolving sum of Fs. Okay, force in X direction. So to get the force in X direction, remember, I taught you earlier that in this direction is positive X, in this direction is positive Y, direction is negative X, direction is negative Y. So now that we are resolving along X, when we take our reference line as Y, we find out that this is the only S force that we have here. This is purely vertical. This force also is vertical. This one is vertical. So the only one that is in X direction, the only one that is S component here is just this 68 cos 45, and it's acting toward the right hand side, which is positive. So this will give us 68 cos 45 degrees. and 68 cos 45 degrees would have given us 48.08 when you impute this in your calculator. So this will give us 48.08 Newton. This is the force. We have obtained that for X. So we do the same for Y, then do the same for moment. That's all about this question. So let's quickly do that for Y. So sum of Y, okay, force in Y direction. So we have sum of Fy is equal to. Now the next is what? We are resolving along Y, and from experience and our previous lessons, we mentioned that all the forces that are acting upward are positive, while the ones that are acting downwards are negative. So it shows that 33 is positive, 68 sine 45 is also positive because it's acting upward, but this guy will be negative because it's acting downward. Are you there? So this will have given us 33 plus 68 sine 45 degrees, then minus 85. This is what we have. Upward plus another upward, then minus downward. These are the vertical component forces. So we have 3 vertical forces here, but we have only 1 horizontal force. This is the difference. So now why we take the ones upward as positive, the ones coming downward negative, and we only have 1 force that is acting downward, and that's the negative we have as negative 85. So when we simplify this, our final answer will have given us 3.92 Newton. This is what your answer will be if you impute these values into your calculator. We have gotten that for Y. You see how simple this question is? Very simple. Then for X, sum of what? Moment at A will be equal to, okay, moment. So for sum of moment, we are quickly going to have clockwise moment minus anti-clockwise moment, because the sum of moment at A will be equal to what? The clockwise moment minus the anti-clockwise moment at A. So we have summation of clockwise moment minus summation of anti-clockwise moment. Remember, I'm using acronym here. CW clockwise, M moment. ACW anti-clockwise, M moment. Okay, so we'll get the difference between the clockwise and anti-clockwise moment. Why? Remember, when you are dealing with moment, clockwise is positive, anti-clockwise is negative. So that's how we have positive moment minus negative moment, right? Which is very, very simple. Okay. Now the next is what? We need to come here. Now remember that we are actually taking moment at A as indicated here. Taking moment about A. That's what we do to actually obtain the single moment or the simplest moment for this structure. Now what do we do? If we are taking moment at A, we need to identify here the moments or the forces that will give clockwise moment and the ones that will give anti-clockwise moment. Now looking at this, remember we already have existing moment here, which is 280 Newton meter. You see, I have not talked about it since because it was not a force. This one that we have here now is not a force. It is what? Newton meter. So anything that you are given in Newton meter is a moment. So this force is this value here is the moment. Now it's the right time to make use of this value. Okay. So now this guy is acting in this direction. And remember, this is anti-clockwise moment, right? This anti-clockwise moment. But now that I'm taking moments here, this guy also will move in this direction. This is equally an anti-clockwise moment. Why this guy is acting like this, which makes this guy clockwise. Remember, this is how clock moves. This is how clock moves. Okay, so when anyone that moves in this direction, we are taking moment at A, so you come to the direction of the arrow. This is how it moves. So this is clockwise. While this one is anti-clockwise, and this other guy will be anti-clockwise. But what about the force 33? 33 will not be taken as moment because 33 does not have a perpendicular distance from A. Remember that moment is force multiplied by perpendicular distance. And now we see that the line of action of 33 passed through the point A. So it is not in any way having a perpendicular distance from A. So as a result, the distance is 0. So when you say 33 multiplied by 0, the value is actually 0. So it shows that here we will have our clockwise moment will be what? 85 times the distance of 85 from A is 4 times 4 minus. Remember, for the anti-clockwise, you can equally have the clockwise first. The only difference is that it's either when you solve it this way, you have a positive value, or when you take anti-clockwise first, followed by clockwise as negative, you have it as negative. That's how it is. That will be the difference. The magnitude will be the same. It's only the direction that will differ. So you can take anti-clockwise first before you take clockwise. You have this in. So that's for that. Then for the clockwise, anti-clockwise, the first anti-clockwise moment we have is already this. So you don't need to multiply by anything at all. 280. Why? Because in itself, it's already what? An anti-clockwise. It's already a moment in itself. So you don't multiply by a distance to convert to a moment because the distance is already being effected. That's why you have Newton meters. So you don't need to multiply by a distance because it's already a moment. It's only force that you multiply by each particular distance so that it can give you the equivalent moment or couple. Are you there? So this is what we have. Then this is plus. Remember that this sigma means summation, right? So plus, since we have another anti-clockwise moment here. So now that we are taking moment here, we have this guy. Alright, we have this guy. So this guy will move in this direction, which we have already indicated. And it's going to give us what? 68 sine 45 multiplied by what is the distance of this force from A? Distance at D. The distance between A and D is 2 meters. So multiply by 2. It's as simple as this. I hope you understand what I have done so far. That's it. That's it. So this is clockwise multiplied by the distance this force is away from A, which is 4. Then minus, which is this negative sign, open a bracket. This is anti-clockwise moment, the first anti-clockwise moment, put it down. Plus, this is another anti-clockwise moment, put it down. Now remember, this is another force again, which will not be considered because each tail is directly connected. The line of action is directly connected towards point A. So it does not have a particular distance. That's what makes this guy and this guy to be what? Ignored while we take moment because their distance is 0. So when you multiply this by 0, it will be 0. And when you equally multiply this by 0, it will equally give you 0. Please replay this video again and again so you can get the concept very well. I hope you understand what we have done so far. Now let's continue. So by the time we multiply this with our calculator, this will give us 340.0. Is that correct? Yeah, so just get your calculator and see how you can multiply this by the distance it covers, which is 4. That's what you have, okay? That's what you have. Then by the time you multiply this, add this to this product of everything that you have here, you have 376.16. Multiply, find 68 cos 45, multiply by 2 plus 280 will give you this. So by the time we remove this guy from this, you are removing a bigger number from a smaller number. We know that our answer will be negative 36.6 Newton meter. You can decide to approximate it to the nearest whole number, which is 36.2 Newton meters or 36 Newton meters. So this is what we have. But assuming it was anti-clockwise moment we took first before the clockwise, this answer would have been positive 36.2 Newton meters. So you are still correct. Whether you have negative here or you have positive here, the value is still the same. Okay, that is how it is. Either you obtain a clockwise moment or you obtain anti-clockwise moment, depending on how you take your assumptions. So from our assumption, we say we are removing anti-clockwise from clockwise. Then another person can assume that he or she is removing clockwise from anti-clockwise. Why is this condition so necessary? Remember that sum of clockwise moment is equal to sum of anti-clockwise moment. So if you take anti-clockwise moment to this end, you will have this. You now decide to take this one to this end, you will have anti-clockwise minus clockwise. So you just find out that you will actually have the same thing. So it's either you take this one to the right hand side so that you have your MA here, or you take this one to this other side where I have the NA here, and this was the assumption we made. So when a positive value crosses the sum of the equality, either from left to right or from right to left, the sign changes to its opposite sign. Okay, so you understand that solving problems in mechanics, engineering mechanics as it were, soil mechanics, fluid mechanics, or solid mechanics like this case of study, they are very, very simple. All you just need to do is to seek to understand the principles. So when you understand the principles, you become a principal. It's as simple as that. So guys, do not be selfish with this video. Do not be selfish with this content. What do you do for us? Help us share this video until it goes viral. Ensure you like this video, give us a thumbs up, share this video, comment on the video, and ensure that you ask necessary questions. Keep following us and you will not regret following us. So we have a very good content for you, which if you check the description below, you will find another good content for your consumption and for your mental growth. We love you. Thank you for watching. See you guys in the next class.